Welcome back to the deep dive. Today, we're wrestling with a bit of a paradox. On one hand, you've got this incredible technology, artificial intelligence,
Yeah.
that promises to just completely revolutionize healthcare,
Mm.
but it's sitting right next to a clinical system that is, well, to put it mildly, already overwhelmed.
Right. Running on fumes.
Exactly. So for you, the learner, we know the hype is real, but
Yeah.
our deep dive today is all about the friction. We've pulled together your sources to answer a really brass tacks question.
Okay.
How do you actually implement these powerful digital tools, especially AI, into a real functioning hospital without, compromising patient safety or just breaking the backs of the staff?
That is the mission. Because the main insight we took away is this. The tech is only as good as the rules wrapped around it. Clinical governance is really the operating system.
The operating system, I like that.
Yeah, it's what turns a promising AI idea, a brilliant algorithm in a lab, into reliable, scalable, and safe care in the real world. If leaders see governance just as a barrier, innovation just dies.
It's a gate.
It's a gate. It has to be seen as a pathway to doing this safely.
Okay, let's unpack this, because we are talking about a serious undertaking here. In the UK, this whole landscape is now defined by a suite of, well, a whole new set of frameworks.
All alphabet soup of them.
Right, you've got PSIRF, DTAC, the ICSF, the MHRA, and of course the CQC watching over it all. Our mission is to figure out how these gears actually mesh. Because they're not just acronyms, are they? They're what determines if AI helps or if it actually harms.
Mm-hmm.
We have to start with the promise, though, because that's the motivation. What are we actually buying into?
Yeah.
Your sources point to three huge areas of potential. First is just greater precision.
Right, like better diagnostics and radiology, spotting things a human eye might just glance over.
And second, efficiency.
Hmm.
This one is huge. We hear that admin tasks can take up, 70% of a practitioner's time?
Up to 70%.
Huh.
AI automating that could unlock billions of hours. It's an incredible thought.
And the third one, which feels a bit more long-term, is this idea of predictive and preventative care.
Yeah, using AI to analyze huge population health data sets to spot risks earlier, to intervene before something becomes a crisis.
It all sounds amazing.
It does. But here's where that friction you mentioned really starts. The rhetoric about the potential is beautiful, but AI's success hinges completely on how it's integrated into existing workflows.
Right.
As your sources warn, if you just drag and drop a new piece of tech into a broken system, all you get is a faster, more expensive broken system, and it just creates more burden for the staff.
So what are the immediate risks if that implementation is, messy?
Oh, they're substantial. If the systems aren't tested properly in a real-world setting, you're talking about serious safety risks. False negatives, for one.
A cancer that's missed because the AI wasn't trained on, say, that specific demographic.
Exactly. Or false positives, which then lead to unnecessary, expensive, and sometimes invasive follow-up treatments. And maybe most importantly, if the implementation is poor, it just makes existing health inequalities even worse.
And that gap, that difference between the clean lab environment and the messy, chaotic clinic, it's just vital, isn't it?
It is everything.
The sources you shared brought up that famous example that just perfectly illustrates this, the Google Retinal Disease Detection System.
Ah, yes. A classic.
It was a technical marvel. I mean, in the lab, it performed just as well as a human specialist in detecting diabetic retinopathy. But then they tried to deploy it in hospitals in Thailand.
And reality hit. The real-world scans were often a bit blurry, maybe lower quality, taken under less than perfect lighting.
And the AI, which was trained on these pristine, perfect images, just started rejecting them. It rejected over a fifth of the real-world scans because they didn't meet its quality standards.
Which meant the clinicians had to go back and manually process all the rejected images anyway.
So the tool became useless.
Worse than useless. It actually added processing time, it wasted resources, and it proved right there that an algorithm's technical accuracy is completely irrelevant if it can't handle the messiness of the clinical frontline.
And that failure is exactly why this UK governance landscape has had to evolve so quickly.
Exactly. Leaders need a structured way to assess and pilot these things with confidence. And that brings us to that suite of mandatory frameworks.
Right. So let's follow the life cycle. The first step is just getting the tool in the door safely.
Yeah.
And that means passing DTAC.
The Digital Technology Assessment Criteria.
Yes.
It's really the minimum bar, the first filter for any digital tool that wants to be used in the NHS.
And DTAC covers, 5 non-negotiables?
5, yes. clinical safety, data protection, cybersecurity, interoperability, and usability. But let's drill down on clinical safety because that's where the rubber really meets the road.
Okay.
It requires developers and the hospitals adopting the tech to stick to these safety standards like DCB 0129 and DCB 0160.
They're not just numbers.
Not at all. They mandate a formal, auditable process for managing clinical risk. You have to identify, analyze, and mitigate risks before the software ever touches a patient.
So if a company fails DCB 0129 because they haven't figured out the risk of a false negative and told clinicians how to handle it,
Then the technology simply cannot be bought and deployed. End of story. DTAC is that essential procurement filter.
okay, so once a tool gets past that minimum safety bar, the conversation shifts. It's no longer, is it safe, but does this thing actually work? Does it save money?
Exactly. And that's the job of the NICE Evidence Standards Framework, or the ESF. Here, governance is all about matching the level of evidence you need to the level of risk the tool poses.
And I'm guessing that evidence bar changes pretty dramatically depending on what the app is for.
Oh, absolutely. Think of it as a spectrum. On one end, you have a low-risk tool, maybe a behavior change app for diet or fitness.
Right.
For that, NICE basically wants to see usage analytics, patient-reported outcomes. It's a lighter touch because the immediate risk of harm is low.
But then you get to the higher risk tools.
And the bar shoots way up. For AI used in clinical decision support, things that suggest a diagnosis or recommend a treatment at 9, demands comparative studies, pragmatic trials, and really robust real-world data.
Data that's tied to measurable outcomes.
Yes, like, does it actually reduce the time to diagnosis? Does it help avoid hospital admissions? It creates this necessary friction. Tech wants to move fast, but medicine needs slow, verifiable evidence.
So even with the best screening and evidence, errors are going to happen. Near misses. It's inevitable with complex AI. So how do organizations make sure they learn from those moments instead of, burying them?
And that brings us to the next framework, PSIRF, the Patient Safety Incident Response Framework. The name really tells you everything. It's about a system response, not blaming an individual.
So for AI, PSIRF is critical because it embeds that learning from incidents across different hospitals, across different trusts.
Precisely. So instead of a doctor getting disciplined for relying on an algorithm that made a bad call, PSIRF makes you focus on the systemic questions. Like, was the training for the staff insufficient? Was the algorithm itself flawed? Was the user interface just confusing?
Yes. It promotes this compassionate engagement. It recognizes that most failures are system failures, not one person's fault. It's the mechanism that ensures feedback actually leads to product changes and refined processes. That loop of continuous learning is just non-negotiable.
And then watching over all of this is the regulator.
The MHRA, the Medicines and Health Products Regulatory Agency, their guidance is pretty straightforward but crucial. Does this piece of software function as a medical device?
And if an AI is used for diagnosis, it probably does.
It very likely is. And that classification then triggers specific conformity requirements for the manufacturer and the hospital, which creates really clear lines of accountability.
So what's beautiful about these frameworks, DTAC, NICE ESF, PSIRF, is that they seem to give health leaders a structured way to say yes to innovation because they know the risks have been managed and overseen.
And potentially overseen by the CQC, the Care Quality Commission.
Yes.
Okay, so we've got the frameworks, but now we have to shift gears and talk about the people. Because all these rules are designed to protect the patient. But what about the workforce? What about equity?
That's the core of it, really. It's clear AI isn't going to replace doctors wholesale, but it is absolutely going to transform the nature of their work.
The goal, I assume, is to make the job better.
The goal is to enhance job quality, to tackle burnout by getting rid of that administrative drag, that 70% of time they're wasting on tasks that don't need a clinical brain.
That sounds incredible. But if I'm a clinician, I'd be worried that the time I save is just going to be filled with another admin task. Or, worse, troubleshooting a faulty new system.
And that's the tension. This whole transformation depends on protecting staff time, for training, for engagement, which is so difficult when the pressure is always on service delivery, on cutting waiting lists.
Yeah.
Your sources are very clear. If staff aren't involved in the rollout, they won't trust the tool, they won't use it, and a badly implemented piece of tech will just add to their workload. It makes burnout worse, not better.
And then there's the other huge non-technical issue, bias. The risk that AI, which learns from our old health data, just ends up codifying and even exaggerating the biases that are already in that data.
It's a fundamental data quality problem. Take AI tools designed to detect skin cancers. They have been shown, time and again, to fail when used on people from ethnic minorities.
Why?
Because the training data sets they learned from are overwhelmingly made up of images from white patients.
Oh.
Your sources cited this one damning study. Out of over 2,000 images that even mention skin color, only a single one was of dark brown or black skin.
One image.
One. So if the data isn't representative, the output, the diagnosis, will be fundamentally inequitable. The algorithm is safe, but it's only safe for the population it was trained on.
And then you couple that bias risk with the risk of digital exclusion. Innovation isn't really equitable if a big chunk of the population just can't access it.
And we're talking about 7% of the UK population with no home internet. Millions of people are at risk of being locked out of these new digital care pathways.
And the people facing that exclusion are often the ones who need the most support.
Exactly. So if we're not careful, the very innovations designed to make the system more efficient will end up disproportionately helping the digitally savvy and leaving the most vulnerable even further behind.
What about the core relationship, the one between the doctor and the patient? If AI handles diagnosis and triage, does that free up time for a deeper human connection, or does it just create distance?
It's a tightrope walk. Automation, especially things like digital triage bots, could accidentally create a barrier. It might limit a patient's access to that essential human judgment and reassurance. AI is brilliant for crunching data, but it can't replace the trust a patient needs when they're talking about something sensitive, especially for groups who already have, historically lower trust in health services to begin with.
Okay, moving from the human element to the structural. Let's talk about scaling this stuff up. The sources mention this huge variability across the NHS. You might have a super sophisticated London trust with perfect data.
Right, and then you might have an organization in a more rural area with siloed, immature data systems. It's really hard to just copy and paste an AI tool across that kind of disparity.
So how do you solve that?
The solution seems to be scaling in partnership and in clusters.
What does that mean?
It means groups of organizations, say a cluster of 5 hospitals or all the ambulance trusts in a region, work together. They pool their funding, they share resources, they look at innovation opportunities jointly.
They build support networks.
Crucially, yes, they build peer support networks for the staff who are actually doing the governance work, clinical safety, cybersecurity. It's about sharing that initial risk and the cost of learning.
And that collaboration allows for local adaptability, which, as the Google example showed us, is desperately needed.
Exactly. It's not one size fits all. So you might have 2 sites piloting an AI for imaging. Site A, with fewer radiologists, might decide to set the AI's threshold for false positives a bit lower.
Meaning it flags more potential issues, even if some are wrong.
Right, to ensure a human eye catches everything, even if it adds a bit to their workload. But Site B, which is better staffed, might set that threshold higher. It becomes a local decision based on capacity and risk tolerance.
Which brings us to what feels like the 2 biggest structural barriers. You can have all the frameworks in the world, but if the foundation is cracked, the whole thing falls apart. The sources really emphasize fixing the basic IT infrastructure.
We need comprehensive, interoperable data. Right now, patient data comes from tens, sometimes hundreds, of different systems that don't talk to each other. The AI is operating with an incomplete picture.
You need seamless data flow.
Using standards like FHIR, yes. You need that before the fancy algorithms can really work their magic.
And the second structural issue, the one that must keep leaders up at night, is legal liability. For high-risk AI, that line of accountability has to be crystal clear.
It needs to be established right across the chain. Developers have to be accountable for their products, but the clinicians using the tools need to be protected too. They have to have the ability to challenge an algorithm's decision without this massive fear of personal legal exposure.
So after all of this, what does it all mean for you, the learner?
I think the key takeaway is that the success of AI in healthcare isn't really about the tech's capability. It's an organizational and a governance challenge.
The sources are definitive on this. The most brilliant algorithm in the world will fail if the framework around it, DTAC for screening, NICE for evidence, PSIRF for learning, isn't robust and fully integrated.
Yeah.
The principles are clear. You have to continuously monitor and evaluate these tools in the real world to make sure they're actually improving care, making jobs better, and not making inequality worse. The governance is the real long-term work. And we've seen how the CQC judges a well-led innovation. It's not just about having the latest shiny tech. It's about managing risk and embedding learning. If organizations use these tools right, AI doesn't just promise better outcomes. It could lead to measurable improvements in things like patient experience. So we'll leave you with this provocative thought. When we talk about an AI making a mistake that affects a patient, where did that ultimate responsibility lie? Is it with the data scientists who trained the algorithm, the hospital leader who bought it, or the clinician on the ground who decided not to override the system? That's the question that will define the next decade of digital healthcare. We'll see you next time on The Deep Dive.